Ulrich, can you tell me a little bit about the OpenScience Observatories? I've heard they're actually in sunny Tenerife.
They are indeed. We have two facilities there, Pirate and Coast, not too dissimilar to the dome we have in the background here, but up on a mountain in Tenerife at 2,400 meters above sea level. Typically above the clouds. It's one of the best observing sites in the Northern Hemisphere, lots of clear skies and a great place to do astrophotography from. We of course use them for astrophysical research.
So the students are actually using the facilities in Tenerife. I'm assuming they don't have to go there to do that. Can you show me how it's done?
Come with me, I'll show you.
So Ulrich, you're going to show me how the OpenScience Observatories actually work.
Yeah, so Pirate and Coast are robotic telescopes and can be set up to work completely autonomously if you request an observation from a schedule, which you can submit to a scheduler. But a more interesting and probably more exhilarating experience for the students is if they log on to a web interface and control the telescope in real time, hands-on, so to speak. The one module where we allow this is called Remote Experiments in Physics and Space, and we ask students to do one of the classical investigations of astronomy to work out the Hertzsprung-Russell diagram of a star cluster. A star cluster is just a field in the sky where a lot of stars are, which formed roughly at the same time. And so what the students do is they image the star cluster in different filters and determine the color and the brightness of many stars. And when they plot this in this famous diagram, they can use it to work out the distance to the star cluster and even the age of the star cluster, which is quite amazing if you think about it, because all they do is taking photographs.
So are you going to show me how that works?
So this is the interface the students have. They are logged onto it. As you can see, there is a webcam stream, daylight at Tenerife. At the moment, it's sunny and blue skies. So right now, unfortunately, we can't open the dome and can't do anything because for safety reasons, we need to protect the kit when the sun is out. It could damage the telescope. But the students, when they are logging on in the evening, have the clear sky in front of them, would check, first of all, if the weather is safe, and one instance would be the wind speed. This tells us, for instance, what the wind was like in the last 24 hours, or low, below the safety limit, so it's safe to proceed at this stage. And the students would then complete this template with their observing request, which they submit straight away and can then observe how the telescope moves about to the target. And the image is being taken right there and then and can be downloaded and looked at straight after.
Well, it's brilliant that students can take a picture. I mean, can they do anything else with the telescopes?
At higher levels, there are more advanced applications. And the example that comes to mind is our module called Astrophysics of Stars and Exoplanets, where we ask our students to observe the transit of an exoplanet. What is an exoplanet? It's a planet orbiting a star other than the Sun. And in cases where the orbit of this planet is aligned such that the planet moves in front of the star once each time it orbits it, it will obscure a little bit of that star and make the star dimmer by a tiny amount, but still detectable. And that's what we ask the students to find. And they record the brightness of the star as a function of time, which is called the light curve. And from this light curve and this dip, they can work out the radius of the planet. And from the timing of the dip, they can possibly deduce if there are other planets in this extrasolar planetary system. So it's quite advanced stuff. It's not just for the students' enjoyment or assessment in this case. In fact, the observation of these exoplanets leads into scientific answers. The ESA's satellite, the planned launch of Ariel in a few years' time, depends on the knowledge of when these transits occur. Because Ariel will observe the atmospheres of exoplanets when they transit. And this effort by our students and other people worldwide helps Ariel pick the targets at the right time.
Well, it's really good to hear that, you know, the data that students are collecting is being used in research. Are there any actual research projects that the telescopes are involved in?
Yes, indeed. Over the years, there have been quite a few PhD theses coming out of pirate data and of work with pirate. And pirate and KAUST are really good for one thing, for observing, monitoring targets in the sky for a long period of time, which would be forbiddingly expensive with larger telescopes. One example is near-Earth asteroids. So asteroids are objects in our own solar system, and they orbit the Sun in the same way as planets do. When they do so, they change their brightness, not just because they are at different distances from Earth, but because they go through what we call phases. Phases like the Moon. If you think about the Moon, which has these phases, it will be brighter or dimmer depending on what moon phase it has. The same is true for asteroids, except it's more complicated there because the asteroids often have an irregular shape. They're not spherical, they have odd shapes. And the phase curve, the phase brightness change will reflect this. And so by observing the phase curve over months or years, we learn something about the shape of the asteroid and the makeup, the composition of the asteroid possibly. And that in turn is really important information for any observation of asteroids, including from spacecraft.
I can see that you're really excited about the experiments and why the students get excited as well, but are they expensive to run?
Well, they cost money, yes. And it's not really comparable to the huge costs of large telescopes or even space-based telescopes, but they need funding. And we try to offset this a bit by commercial activity. One example being space debris, space junk, of which there's a lot in Earth orbit and which is very dangerous to satellites in Earth orbit. And KAUST in particular is involved in tracking space debris so that we know where it is now and where it might be in future to basically make satellites safe.
Well, it's really brilliant that, you know, students are doing research, they're monitoring space junk. I mean, I'm guessing you've got to be pretty good at astrophysics to use these telescopes.
Well, luckily not. We have a public-facing interface, telescope.org, and a free batched open course on OpenLearn called Astronomy with an Online Telescope, where anyone really can learn about how to use the telescopes, what it means, and they get a free photograph of their favorite nebula or galaxy in this way on the telescope. And they can also take part in a citizen science-like study of variable stars.
That's fantastic.
It is. I'm always very, very excited about the telescopes because of the possibility. There's a small chance each time you take an image with this telescope, there is a chance that you may discover something new. You may be the first one to see it.
That's brilliant. Thanks so much.